Hello everyone, we're back again in the general chemistry lab. This is our last virtual experiment this semester. We're talking about electrochemistry, specifically galvanic cells or voltaic cells. I've discussed this with Dr. Blas. He told me you have not started that chapter yet. So this is going to be basically my way of helping you understand lecture material better when it does come, probably sometime next week, but after we do this lab. So for this lab, it's more or less a demonstration. You will have to fill out the data sheets that's in your lab manual. We'll talk about it towards the end of this pre-lab lecture, but you will not have to do the post-lab. And you will record observations from what I'm going to show you. And in this lab, we're basically going to demonstrate to you what galvanic cell might look like and how you measure voltage generated by such a galvanic cell. But before we talk about that, let's consider a redox reaction between metallic zinc and copper sulfate solution. We've talked about redox reactions in Chem 1240. I asked you to complete a pre-lab, which basically is designed to help you review the notions we use in this instance. So here we have metallic zinc, which has a charge of 0. So we're going to use a strip of metallic zinc containing zinc atoms, which are neutral. And we're going to consider a reaction between zinc and copper sulfate. Copper sulfate is an aqueous solution containing copper plus 2 ions. So atoms here, ions here. And the reaction then produces zinc sulfate and metallic copper. Just to remind you a couple of things, we talked about the fact that this is an example of single replacement reaction where more active metal, in this case zinc, replaces copper, which is less active metal compared to zinc, replaces less active metal from its salt. And we also talked about the fact that charges change. So zinc starts out at 0, ends up at positive 2 as an ion in aqueous solution. Copper, on the other hand, starts out as a plus 2 ion in solution, ends up as metallic copper, which consists of neutral copper atoms. So the charge here is 0. So how do we know that this reaction even occurs? Well, what I have here are 2 beakers, which are going to be sort of precursors for my galvanic cell. So in this beaker, you can probably guess I have copper sulfate solution. You can tell by its color. And what I did is I placed a strip of zinc into copper sulfate. I did it literally 5 minutes ago, not that long ago at all. And in this beaker, I have zinc sulfate. I labeled this beaker because zinc sulfate is clear and colorless, so you could not tell it from water. And I put a strip of copper metal into zinc sulfate. What am I trying to do here? Well, I'm trying to show you which reaction will actually occur versus the one that will not. So let's consider this copper. Hopefully you can see that the bottom portion of the strip is no different in appearance than top portion. Well, maybe it is slightly different because it's simply wet, so it's a little shinier. But it certainly doesn't show any sign of chemical reaction beyond that. So will copper metal react with zinc sulfate? No, because copper is less active metal than zinc, so copper cannot replace zinc from its salt. This, however, is a completely different story. So one thing you may notice, I don't know how well you can see this, but solution is kind of cloudy now. It started as clear and it is now cloudy. But most importantly, let's take a look at the surface of the zinc strip that was immersed into copper sulfate. You can clearly see the border between the original zinc, which remains gray and shiny. I did clean it with sandpaper right before I put it into the solution. and this bottom portion, which was immersed in a solution of copper sulfate, you can see it's now completely different in appearance. It appears black, and there's this black powder-like material, which I rubbed on my finger a little bit to show you. So here in this beaker, there is an apparent sign of reaction. So what is going on here? Well, what's going on here is that copper ions from this solution turn into copper atoms and begin depositing on the surface of the original zinc strip. So this black powder-like material on the surface of this strip is actually tiny atoms of elemental or metallic copper. So let's go back and talk a little bit more about this reaction. So just to remind you, we talked about how to tell which species are being oxidized and which were being reduced back in 1240. We mentioned that substance losing electrons is oxidized and substance gaining electrons is reduced. So in this instance, zinc starts out at 0, ends up at positive 2. Considering that electrons are negatively charged, it means zinc is losing electrons. And so zinc is being oxidized. Copper ions, on the other hand, start out at positive 2, end up at 0. To go from positive charge to neutral, species must acquire or gain electrons. So copper in this case goes from positive 2 to 0, gains electrons, and is being reduced. When we talk about electrochemistry and galvanic cells, it's helpful to consider what's called half reactions. We're basically considering oxidation and reduction separately. This, by the way, is the same reaction, equation describing the same reaction as this one, only this is net ionic equation, so I got rid of sulfate anion because it doesn't participate directly in the reaction. And so then I can split my reaction into half reactions, showing oxidation and reduction separately. So here we have zinc starting at 0, ending up at positive 2. So again, question that you should be answering yourself right now is zinc oxidized or reduced? Reminder, you can use Leo said GER, lose electrons oxidize, gain electrons reduce, or you can use oil rig, oxidation is losing, reduction is gaining, to help you answer. So from neutral to positive, this means that electrons have been lost, so zinc loses 2 electrons. Copper starts out at positive 2, ends up 0, gains 2 electrons. So here you would write minus 2 electrons, and here you would write plus 2 electrons. So copper here is being reduced, and zinc here is being oxidized. So how can we use this information to construct a galvanic cell? Well, let's take a look at what we're going to do next, and you're going to see it in experimental perspective in a second. So next what I'm going to do is I'm going to take 2 beakers. One will contain copper sulfate solution. The other one will contain zinc sulfate solution. But instead of putting copper strip into zinc sulfate, look what I'm doing here. I'm taking a copper strip and I'm putting it into copper sulfate solution, creating one part of my galvanic cell, or one of the electrodes, while in the other part I will have zinc sulfate with a zinc strip placed into it. So what I have here is I have same reaction, but I have separated it in space, so I can conduct the reaction in 2 separate beakers. What's going to happen is I'm going to take a special meter and I'm going to attach the wire from the meter to the copper strip and to the zinc strip, so we can see what happens and how voltage is produced. This here is what's called the salt bridge. Because the 2 reactants are separated into different beakers, I need to make sure there's still a way for ions to travel from one beaker into another. And so salt bridge is going to be constructed from filter paper soaked in potassium nitrate solution. You can read about the exact procedure and step-by-step instructions in your lab manual. I will tell you page numbers in a minute, but we're going to take a look at such cell, and what we're going to see, of course, is that on the copper strip here, electron gain is going to occur. So electrons are going to transfer from zinc strip through the wire and then into copper sulfate solution, and as a result, zinc is going to be dissolving, this electrode is going to be dissolving, turning into zinc ions. Here, and copper is going to be depositing, because copper ions are going to travel through the salt bridge and deposit on the zinc strip, just like we did in the beaker I showed you a minute ago. And here in copper sulfate, what we're going to see is that copper sulfate is going to, I don't know if we're going to actually see it, but copper sulfate may lose some of its blue color, because copper sulfate is going to lose copper ions, which are going to be converted into copper atoms depositing on here. So we're going to take a look at that. First, let's briefly talk about the procedure. So in order to complete the data sheets, you will have to read pages 175 through 181. So 175 through 181. This describes the background information, explains how electrodes are named and everything, and how half cells are constructed, gives a diagram showing galvanic cell in figure 1 on page 177, and then procedure actually begins on page 180. So we're now looking at part 1 of the procedure, studying half cell potentials. And like I said, you will not have to complete the post lab simply because you have not done this in lecture yet. But I think after watching these videos that I'm trying to make very clear for you, you should be able to complete data sheet 1 and data sheet 2. So pages 185 to 187. So those 3 pages will constitute your report that you will have to fill out and upload to Canvas. And these will be due during the week of May 4th. So in the next video, we're going to take a look at the actual galvanic cell.